So the next session, in fact, the next two sessions, we'll see science collaborations contributions. So we'll hear from a speaker from each of the science collaborations. Each speaker has 12 minutes to talk, receive, and answer questions. So stay on time. I think it's 10 minutes talk and 2 minutes on Q&A. So I will give you a warning at 8 minutes into your talk. I'll shave off some 15 seconds from each talk to make up for the 2 minutes behind. The first speaker is from the AGN Science Collaboration, and it's Paolo Coppi, hailing from Yale, or rather, probably sitting in Yale.
Yeah, exactly. Yeah. Okay, thank you. Can you hear me, everybody?
Yes, and I will give you an 8 minutes warning.
Okay, so do I share screen? Is that, do I have permission? Let's see. Okay, can everybody see my PowerPoint?
Yes, we can.
Okay, thank you. All right, so I'm here on behalf of the AGN Science Collaboration, and this is a rough picture of where we are 3 years ago, and the most important coordinate is Neil Brand is our leader, and that's his email address, and this is the mailing list for the AGN Science Collaboration if you're interested. So let's see, next page. One of the reason why AGN people are excited about LSST is because when you run through the numbers, no matter what you do, you will end up with a very large number of objects. So there could be 300 plus million in principle accessible, but 20 to 50 million could be objects that we could watch and do their stuff. And of course, one of the characteristics of AGN is they're active and they vary a lot. They've got a, by galactic standards, a small supermassive black hole at the center that can do crazy things on sort of hour timescale, even minute timescales in the case of blazars. So, so we're excited by the possibility to do real population studies now. The one takeaway for the other people who are not so excited about AGN, they're all over the place. And if you look at variable blue objects in the sky in particular, they kind of tend to dominate things. So our gold, I'll say later, can be your junk. So it behooves you to get rid of our stuff, which is good for us because you'll tell us where the AGN are. So removing AGN or finding AGN could be a useful broker function. Okay, so what about, why do we care about variability studies? In general with LSST, that we have the possibility to obtain millions of well-sampled light curves with different colors. And you can do things like reverberation studies, map how stuff moves in the accretion disk. This is an example of showing how the break, there may be a possibility, for example, to measure a black hole mass by looking at the variability power spectrum. And where you see a break, the break could scale with the Eddington luminosity. That's not the black hole mass, although there's a mass there, but it could also scale directly with the black hole mass. And as we're learning, we've only seen the tip of the iceberg in terms of types of variability. The characteristic timescales for stuff to happen on the accretion disk, the viscosity timescale can be 100,000 years, but we see quasars, changing quasars, dramatically changing their apparent accretion disk emission on few week to month timescales. So there's lots of cool stuff. There's jets flying out. We haven't really seen the full spectrum of AGN variability. So by looking at potentially millions of objects, that's what we hope to do. And the brokers, of course, are essential for that. So some more about why AGNers need LSST and LSST alerts. I'm mostly a theorist, so we've learned the hard way, that you really need multi-wavelength, lots of different wavelengths to see what's going on. The AGN phenomenon goes from radio all the way up to very high energy gamma rays at 10 to the 12 electron volts. So I took out the page, the previous one, but a lot of the instruments we need to study the AGN, some of them are wide field, like Rosita might be wide field, but a lot of them are not. So we have to decide what objects are interesting to point at, in particular when, because a lot of time they're doing nothing. And to the chagrin of many, hard experience also demonstrates that a snapshot SED of an AGN is not that useful. There are many degeneracies in AGN models, and AGN are intrinsically variable systems. If I show you one snapshot 10 years ago, there are a lot of things you can argue about that will never get resolved. So right now we can only probe down, in particular to the center, and actually see what's going on for one supermassive black hole, an M87. For the rest, if we want to actually do physics and learn about what's going on at the center, and people outside the AGN field sort of care about AGN physics because AGN seem to throw up a lot. In other words, feedback and mess up their environment and limit star formation in galaxies and things like that. So if you want to understand how much energy a black hole outputs as it accretes to larger scales, you have to do the physics. And therefore, since we cannot have the spatial resolution, we need to probe, we need to rely on the variability to do that. So that's why it's important. So in terms of what the brokers can do, one of the most dramatic examples of what can happen to a black hole that should be relatively easy to catch, except there's a big background, is when a star, for example, falls into a dormant black hole that's not accreting any gas, temporarily it gets shredded, gets tidally shredded, pulled apart, and the gas forms an accretion disk and falls in. That's the so-called tidal disruption event. So these will be really cool. The luminosity goes, or the accretion rate goes from essentially 0 to super Eddington, in some cases on time scale of months to a year. So it's pretty dramatic, and it's a good laboratory to probe how an accretion disk responds as the accretion rate ramps up and down over a large range. Okay. Another cool thing that should be hopefully possible is not only will we have lots of variability, time variability information in sort of fixed filters, but there's more and more spectroscopy coming online. I still think LSST will be spectroscopy starved, but there are things like the Foremost survey coming on, and Sloan 5 is going to also be taking lots of spectra. That opens a possibility of reverberation mapping, for example, seeing how the AGN emission lines respond to changes in continuum, and different emission lines are produced in different places, so you can probe the environment. And this is going to be a very powerful probe. The problem with that, though, is that a lot of these telescopes, although they may take repeat observations, I'm thinking about a Foremost proposal right now, you have no idea when the observations are going to occur, okay? And there are objects like these, which are sort of one of the examples of cool things that's happened we've noticed in the last 10 years, changing lit quasars, okay? So this is a sort of blue dead quasar with narrow lines, so maybe obscured. Suddenly, though, much later, it flips side and then now becomes a broad emission line quasar with a very blue continuum. So it completely changed from a dead, who knows what type 2 AGN to a type 1 AGN. Okay, so obscured to unobscured. And there are many more cases of these, and we think we're going to find a lot more of these. This transition, if you're looking over here, can happen fairly fast, within months sometimes. So if, and in order to unravel what's going on, we'd like to ideally see how this emission line shape changes. And if you only have broadband sort of photometry, a lot of times,
2 minutes.
Okay, thank you. The change in magnitude from here to here is only like 0.1 magnitudes. You lose all information just from photometry. It's much harder to extract. So if we can trigger and get spectra in real time when we need it, that's super important. Okay, so you can also do things like track microlensing events. Okay, and so now I talked too long, but so you can also find blazars. They do cool things, and you can also wait for sources to dim. The AGN and the host galaxy contamination is always an issue, so you can wait for the AGN to turn off and then learn about the M sigma relation for that particular galaxy. All right, so what specific things have we thought about that brokers would need to do? In my remaining 2 minutes, so less than 2 minutes. The nuclear region is a messy place. Here's one general comment. To really figure out what's going on, a lot of the changes in broadband photometry are at the percent level. So we really need good differencing, okay? And which reference frame you use makes a difference. And also, even though there are rapid variability on 2 or 3 day timescales, like the tidal disruption event, there are a lot of things that are not rapidly variable, okay, that happen on weak timescales. So there's likely to be a lot of intra-data release science that sort of between year timescales that LSST alerts will actually not capture. And a concrete example of this is right now, ZTF is only seeing 1 out of 20 optically variable AGN in the alert stream. And if you look in the data release, you can find many more examples of AGN. That probably has to do with the amplitude and the time scale of the variations, and also host galaxy confusion. So one question that we raised in the previous broker meeting, can we have our own dedicated pipeline or not? What's proposed right here is probably beyond the scope of what brokers can do, but if there are any science team members, can we insert a proprietary plug into the data stream and get access to imaging data and make our own sort of pipeline? And that raises a broader question for brokers. Can they access proprietary data now? That was discussed like a couple of years ago, the first broker meeting. Can public triggers be based on proprietary data, or can brokers provide proprietary triggers if you can't release that data? Okay. Couple more thoughts. Down to magnitude 21, which is the limit for 2 to 4 meter spectroscopy, which is the only one we'll really have readily available. We actually already have a lot of AGN variability data. There are lots of things in the Southern Hemisphere too. That's enough to pre-identify a lot of LSST AGN.
Paolo, you can choose whether to
run into, okay.
Or take your questions.
Okay, all right. Yeah, let's see. Okay, let me just finish this and then maybe we'll talk about it later. Right, so it'd be good to have a capability to change what the brokers do in triggering, and in particular, let's see, could machine learning is getting better. Okay, so while the brokers already provide some machine learning classification, is there a possibility to input your own preferred model later, which may take computational resources that are developed by AGN domain experts later? We want to watch a lot of objects, so a lot means millions of objects. Is that feasible with brokers? Can you archive the alert light curves for us and provide extended light curve information for persistent objects? If after the start of the experiment, could the brokers automatically link to the data release data if available to give us really extended light curves? And then can we use that extended light curve to trigger or place filters on things? And also, we've talked about, other people probably will talk about inclusion of multi-wave catalogs, but can we take those catalogs and include from those catalogs higher order entries that in a table, such as a bolometric luminosity, stuff that you just don't download off the web. Someone has to process it, and then we want to input some other pieces of data that might be useful for filtering. It's not the stuff that you pull off, for example, the masked archive for pan-stars data. It's not colors. So I think I will stop there, and I ran over, but.
So let me introduce my partner, Nina Hernishek. I hope I didn't butcher your name too much, who is the co-moderator on this session. She would normally now take a question for Paolo, but we did run over. So if we have time at the end of the session, we'll turn around and go back to Paolo and ask questions. Also a reminder to put your questions on Slack so that Nina can collect them and ask them